Hello guys, welcome to the channel. Today we will discuss support vector machine SVM algorithm for regression. Okay. In previous video we saw how we can use support vector machine algorithm for classification. Okay. So first understand what is SVR. SVR stands for support vector regression. It is the regression version of SVM algorithm. Okay. It predicts, SVR predicts continuous value, not categorical values like cat, dog, okay, red ball, blue ball. Those are categories. It predicts continuous values like house price, salary, temperature, stock price, like that. Okay. So, what is the main idea of SVR? Basically, it fit the best line inside a margin or boundary. I will explain it through a graph. Okay. SVR says small errors are okay, but only focus on points with large errors. The on those points which have large errors, it adds penalty to them. For small errors, it neglect that. Okay, so this is the main concept of SVR and margin. What is margin? Margin, like you can understand it. If prediction error is small, ignore it, or if error is outside the margin, then add penalty to them. Okay, this is what is the concept of SVR, the logic of SVR. Now you can understand by this graph. Here you can see the data points like this. Okay, like this. Okay, these orange dots. These are your data, actual data points, and it drawn a prediction line with respect to those data. Okay, so this is how it tries to predict from those actual data points. Okay, this is how it makes prediction. So we will see how we can use support vector machine for regression. And last thing, kernel. I have already explained what are the kernels in my classification. Basically, kernel which converts low-dimensional data into higher dimensional issues. There are four types. Linear kernel used for linear data, polynomial kernel. When we will not have linear data, we will have some curved like shapes in our graph. Then we will use polynomial kernel. RVF kernel for complex non-linear data, and sigmoid we will use it later when we will cover neural networks. Okay. So kernel concept is basically similar to for regression. Okay, so on this data set I have where I have total experience and certifications as my input column, and my output column is salary. Okay, so we will apply my SVM algorithm for regression on this data set. Okay, so let's see how we can do it. First, I will import some required libraries as np import pandas spd import matplotlib dot pyplot splt import seaborn as essence. Okay, now I will load my data. pd.read slash csv. This is my salary multi.csv is my data set. I will right click, copy path, paste it here. I will check it first three rows. So yeah, my data gets loaded and these are my first three rows. Okay. Now, suppose I will plot a graph to show how my data is looking like. Fixed size, comma to SNS dot scatter plot scatter plot, I will give X as my total experience, Y, I will give Y for certification, okay, and I will give my data as my data because in the data variable I have saved the data. I will take Q parameter salary. Okay. Now, sorry, plt dot show. Okay. So this is how my data is looking like. Okay. Now, first I will basically divide my data set into input and output minus one means I give me all the rows and all columns, but minus one means but don't give me the last column, which is my output column. I will take output column into Y. Okay, my data gets divided into input and output. Now, I will divide my data set into training data set and testing data set. Okay, model selection, import, train test split. Okay, now I will take my all four variables x train, y train, sorry, x test, y train, y test is equal to, I will call train test split. Yeah, I will give x and y. I will give test size as 0.2. I want 20% as my testing data and 80% as my training data. So I give test size equal to 0.2 and I will give random state is equal to 42. Okay. Now I will create my model from sklearn dot svm import SVR because we are dealing with regression problem. For dealing with classification problem, we import SVC. Okay. Now, now suppose I will create an object to call SVR. Okay. Now I will give kernel. I have already explained in my previous video also where I explain SVM algorithm for classification, what kernels are, and in this video I also gave an overview what kernel, what is kernel. Okay, now suppose I am giving my kernel as RBF. There are total four kernels. I will write it here. Linear. Okay. Second one is polynomial. For polynomial, we just write poly. Okay. And third one is your RBF. Fourth one is your sigmoid. Okay. So, so I have already explained how we can use different kernels according to our situations. Okay. For example, if we will have linear data, then we will apply linear polynomial for basically when we will have some curve like features, then we will use polynomial kernel RBF when we will have complex or non-linear data, and sigmoid we will not use this now. When we will cover neural networks, then we will apply sigmoid kernel. Okay. Now these are the four types of kernels. So first, let's suppose I'm taking RBM. Okay. Now I will fit X train and Y train. I'm training the model by my training data. Now suppose I will check my accuracy of the model. X test comma Y test into 100. So this is giving very low accuracy. Okay. RBF. Okay. Let's suppose I will take linear. Okay. So by linear, I am getting 71% accuracy. Okay. Now let's take poly. By poly, we are getting 59 accuracy. So for now, I'm only giving linear because from linear, we are getting some high accuracy, not like high, better than these two kernels accuracy. I'm getting 71% accuracy. So we are getting low accuracy because we have not standardized our values. Okay. So we need to perform standardization. Okay. So I'm not covering standardize in this video. I have already covered how we can perform standardization and why we perform standardization in my previous video where I covered data preparation. You can check that playlist. Okay. So uh, this is how we can use, you got an idea, right? How we can use SVM algorithm for regression problem. Okay. So uh, that's all in this video. And we also like covered how we can use different kernels according to our situations for regression problem also. So that's all in this video. In the next video, we will cover hyperparameter tuning. Okay. So that's all in this video. Thank you.